Good morning, everyone. In the last session, we have discussed in detail about the bioproduction of various products, including vitamin B12 and streptomycin. In today's session, we will try to understand a newer concept in the unit 3 of the syllabus, that is about industrial enzymes. We will be discussing about the production and uses of the industrial enzymes with emphasis on proteases. So, as a prelude, enzyme technology is a fast growing branch of science and technology. It is an ever evolving branch of science and technology, and it takes the help of knowledge from biotechnology and bioinformatics. So, it is a conglomeration of biotechnology and bioinformatics which makes the enzyme technology an ever evolving branch of science and technology. And nowadays, there is a need for improved enzymes for the reason that these enzymes are finding novel applications. So, the need for enzymes with improved properties, and it is also growing parallelly or emerging simultaneously so that it can meet the demand for novel applications, right? So if you just look at the enzyme technology business, development of commercial enzymes is a business now. It is a specialized business, and not everyone can do this kind of business. The companies which have specializations or which have mastery over certain factors can do such a specialized business of developing commercial enzymes. Now, what are those criteria or factors the companies possess? The companies which possess high skills in number one, screening of or screening for new and improved enzymes. So there may be several companies which are specialized in only the screening process for new and improved enzymes. So such companies can go ahead with the development of commercial enzymes. And the second factor is fermentation for enzyme production. The companies which have the capability to undertake the process of fermentation for the production of enzymes in industrial scale. And number three, large scale enzyme purifications. Companies which are capable enough to purify enzymes in larger scales. And number four, formulation of enzymes for the market or for the sale. So these are some of the skills or high skills which the companies possess can undertake the development of enzymes for commercial uses. Right. And nowadays we are seeing that there is an alternate for aggressive chemical processes to produce the product. And this alternate is by the use or applications of different types of enzymes. So enzyme technology is offering both the industries as well as the consumers an alternative source to process or to get the product with mild and environmental friendly activities or events, right? So there is a replacement for aggressive chemical process. The replacement is by the use or the application of the enzymes. So this opportunity is given to both the industries as well as to the consumers, so that a mild and environmental friendly events or activities lead to the development of a product. In spite of this, only about 5% of the chemical products are produced using enzymes. It's only 5% of the chemical products, even today, they are produced using enzymes or the biological route. Although we have about 3000 plus enzymes which are or have shown commercial value or importance. But still, only 150 to 170 of them among 3000 are being extensively exploited for industrial use. So that accounts for only 5% of the chemical products that are being produced with the use of enzymes. Though we are having 3000 plus enzymes which are capable enough to be exploited for use in industries, but only 150 to 170 of these enzymes among 3000 plus enzymes are being extensively exploited for industrial use. Right. So based on different application sectors, the industrial enzymes are classified. So you have seen the enzyme classification, the basic classification of enzymes into 6 groups. Now, with respect to applications, that is different applications, the industrial enzymes are classified as number one, enzymes used in food industry, enzymes for processing aids, enzymes as industrial biological catalysts, enzymes in genetic engineering experiments, and enzymes in cosmetics. So these are the 5 broad classifications of industrial enzymes from application point of view. That is number one, enzymes in food industry, enzymes for processing aids, enzymes as industrial biological catalysts, enzymes in genetic engineering, and enzymes in cosmetics. So they have offered an economical feasibility, and these enzymes when used in industrial scale or the processes to produce the product are eco-friendly. So they are the alternatives to physico-chemical and even to the mechanical processes which many of the industries use. Right? So with the pace of time, the enzymatic process have become or have shown to be the most promising alternatives to physico-chemical processes and even to the mechanical processes used by the industries. So industries are shifting to the use of enzymes to produce the product because they are economically feasible and most important, they are eco-friendly. Now, if you start comparing the commercial process, that is the chemical process versus the enzymatic process, most of the chemical process or enzymatic process, they are driven by higher temperatures and higher pressure. So what happened? What is the consequence of this? It leads to high energy cost and needs higher volume of cooling system or cooling water. So in turn, it adds or increases the capital investment. So if you just look at the commercial process that is being used or which is existing and these industries now they are looking for enzymatic process. process, if you just compare the commercial process versus the enzymatic process, these commercial process, they are dependent on high temperatures and high pressures. So what happens? It leads to high energy cost and needs larger volume of water to cool the system. So ultimately it increases the capital investment. And second thing, harsh process require higher pressure, temperature, acidity or alkalinity. So all these factors necessitate heavy investment to design a specific unit or an equipment or an unit operation to handle these extreme experimental conditions. Right. So most of these processes generate undesired byproducts. That is the most important limitation when we compare the commercial process with enzymatic process. And if you find the generation of undesired byproducts, the next important limitation is it is very much difficult to separate, and even if you try to separate, it exerts harmful impact on the environment. That is, they are not eco-friendly. Right. So harsh process which requires higher pressure, temperature, acidity or alkalinity. So all these necessitates to higher investment, and most of the time you end up with byproducts which are undesired and difficult, very much difficult to separate, and even if you try to separate, it exerts harmful impact on the surrounding or the environment. So in contrast to this, use of enzymes in these processes is the best possible alternative. To give an example about the use of water, because industries consume billion liters of water, if not at least million liters of water. To give an example, in textile industries, about 70,000 to 90,000 liters of water is used for 1 ton of knitwears, which can be saved by employing the enzymes. If you go for chemical process, it requires 70,000 to 90,000 liter of water for 1 ton of knitwear. So if you are employing enzymes, you can automatically save the huge amount of or the volume of water. So if you just translate into the global scale, approximately 9 million tons of knitwear is produced annually worldwide. 9 million tons of knitwear is produced annually worldwide. We are just translating into the global scale. So it's about 70 to 90,000 liters of water for 1 ton of knitwear if you are going for the chemical process. And if you just translate it into the global scale, it will be 9 million tons of knitwear which is produced annually. And it consumes about 630 billion liters of water. Because we know that most of the countries don't have even 1 liter of good drinking quality water. And see how much of water is being used or consumed by the industries. I'm just giving you an example of one industry, that is textile industries, only one segment. There could be much more consumption of water in several other segments or industries. Just from industry, textile industries or textile segments, it's about 630 billion liters of water that could be easily saved if the products are produced using enzymes. So this is the difference which the enzymes or the use of enzymes make contrary to the chemical processes. Right? Okay. So if you just recollect different classes of enzymes, we have six classes of enzymes, that is oxidoreductase, transferase, hydrolase, lyase, isomerase and ligase. So among these six different classes of enzymes, I would like to mention some of the commercially exploited enzymes associated with each groups of or each classes of enzymes. So catalase, glucose oxidase and lacase from oxidoreductase class. Then we have fructosyl transferases, glucosyl transferases, amylases, cellulases, lipases, pectinases, mannanases, phytases, proteases, which we will be emphasizing more on these. So these are associated with transferases and hydrolases. Then we have pectate lyases, alpha acetolactate decarboxylases associated with lyases. And then we have glucose isomerases, epimerases, mutases, lyases, topoisomerases associated with isomerase class. And then we have argininosuccinate glutathione synthase associated with ligase. So these are some of the important industrially exploited enzymes or enzymes used in industrial process and its association with the different classes of enzymes. Right. So today, currently or in a present situation, industrial biocatalysis is viewed as the third most important sector next to the pharmaceutical sector and agriculture sector. The reason is use of enzymes in the industrial process happens at room temperature and mostly under aqueous conditions. So the enzymes which are capable enough to produce the product in the purest form and in bulk quantity are capable enough to do so at room temperature and under mostly aqueous conditions. So industrial biocatalysis is viewed as the third most important industrial sector next to the pharmaceutical and agriculture sector. Right. So industrial enzymes are becoming or they are creating or they are the most attractive molecules for the reason that not only because they are highly efficient in the process, not only because they exhibit specificity for substrate to product bioconversion, but also because they are capable enough to catalyze the production of relatively pure form of the product. So what is the consequence of this? It results in minimizing the waste or the undesired molecules or the compounds. Right? And the most important tagline is all these biological reactions they occur under mild conditions. So there is no requirement for higher temperature or higher pressure. These reactions they occur under mild conditions. Right. So biological catalysts are attractive from industrial point of view or from the industrial purposes, not only because they are highly efficient in the process, not only because they are specific in substrate to product bioconversion, but also because they are capable enough to produce the product in a relatively purest form, so that results in minimizing the waste generation or undesired product molecule or the product or the compound generation. And the most important feature is these reactions, they occur under mild conditions without any requirement such as higher temperature or higher pressure. So if you just look at the microbial enzyme production, use of aerobic submerged culture in a stirred tank reactor is a typical fermentation process or the industrial process for the production of enzymes involving the microorganisms. And it is expected that these microorganisms secrete the enzymes into the extracellular medium. So microorganisms that produce extracellular enzymes are preferred, right? And this table gives you an idea about different enzymes, microorganisms, that is microorganisms involved in enzyme productions with several applications or potential applications in various industries. You can see a list of microorganisms and the enzymes produced by these microorganisms. We have amylases from several species. To give an example, Aspergillus oryzae. Then we have proteases from Aspergillus niger, Pseudomonas species. Then we have cellulase from Trichoderma species, the Penicillium species. Then we have xylanases from Bacillus species. Then we have lipase from Oryzae, phytase from Aspergillus species, invertase from Saccharomyces, lactase from Aspergillus. Then we have catalase from Aspergillus, then pullulanase from Klebsiella, then we have glucose isomerase from Streptomyces species. So it is an important information to understand what are the different types of microorganisms are exploited to produce different types of enzymes at industrial level, right? So when you select the microorganisms, usually the microorganisms when selected or employed, they belong to the GRAS component, that is generally recognized as safe. So whenever you choose a microorganisms to produce enzymes at industrial scale, these microorganisms are or need to be under GRAS component, that is generally recognized as safe. So GRAS category, they should belong to the GRAS component or the GRAS category, especially if the products are to be used in food and feed industries. So it is mandatory if the products are supposed to be used in food and feed industry. So whenever the microorganisms employed, they should belong to the GRAS category. That means generally recognized as safe category, right? And second thing is there is a lot of attention given to isolate the microorganisms with extremophilic properties. So that could be from rainforest to arid region and from the bottom of the ocean too, so that they could or they are capable enough to produce enzymes with a promising industrial feature or the nature that is required. So there is a lot of research that is happening to get the enzymes from different sources. It could be from rainforest and up to arid region and even from bottom of the ocean, that you can get the sources, the enzyme sources that could produce microorganism sources that could produce enzymes with a promising industrial feature or the nature, right? And when you're selecting the strain for industrial enzymes, important factor is that the strain should produce the enzyme extracellularly. So this is most important. If the strain is not capable enough to produce the enzyme extracellularly, then purification and recovery becomes very difficult. So the strain what you have selected should produce the enzyme extracellularly, as it makes the purification and recovery easier. If it is producing intracellularly, then it is very difficult. Again, there is capital investment for that, and maybe we may not get the purest form of the enzyme. And process characteristics, that is fermentation process characteristics such as viscosity or even the recoverability, the legal clearance of the organisms should also be considered before selection, because you are working on microorganisms. So legal clearance to use the microorganisms should also be one of the important factor before selecting the microorganisms to produce the desired enzyme. Now, as I said earlier, it is about submerged fermentation, which is the best choice for producing industrially important enzymes. So, this is a preferred technology for industrial enzyme production due to ease in handling at larger scale. So, in comparison to the solid state fermentation. So this is a generic illustration about both submerged fermentation and solid state fermentation. If you just look at in the illustration carefully, the upper part of the illustration is about submerged fermentation and lower part is about the solid state fermentation. And under submerged fermentation, we have the culture plates, and then you take it up to the shake flask culture, and then we have the seed fermenter, and then we go for high production fermenter, and then the biomass separation occurs. On contrary to that, we have a slant culture in solid state culture, then we have shake flask or solid state culture, then we have tray fermenter or rotating drum fermenter, and then homogenization of the solid substrates, and then finally we go for separation of the biomass. So following this is the concentration, purification, and modifications, if any, required, and then we go ahead with adding some of the preservatives if it is demanding, that is through mixing or blending, and then we go for drying and heating. Processed liquid product can be obtained, or processed powder product can also be obtained. Right. Here, what happens in submerged fermentation? As we know that the medium in submerged fermentation is liquid. That means it remains in contact with the microorganisms, and the supply of oxygen is essential. In that is, it is mandatory in the submerged fermentation. That is done by the help of the spargers, and there are stirrers and impellers, and their design play an important role in these fermenters for equal mixing of the air, biomass, and the suspended particles. Right. So if you just look at different ways of submerged fermentation, they can be: number one, the batch culture, and number two, the fed batch culture, and number three, the perfusion batch culture, and number four, the continuous culture. So these are the four main ways of growing the microorganisms in submerged fermentation. That is number one, the batch culture, the fed batch culture, the perfusion batch culture, and the continuous batch culture. So this is about an introduction about the industrial enzymes and how the industry pursue about these enzymes, and why the enzymes are serving as an alternative source for commercial process, sorry, chemical processes, and because of several advantages as we have discussed and understood. So I'll stop my discussion over here. We can continue our discussion in the next session with more emphasis on the production and use of proteases. Of course, there are several other enzymes as we have seen in the table, but your syllabus mentions about specifically about the proteases, and we'll see how the production and applications or uses of proteases happen, and what are the different microorganisms that are capable enough to secrete these enzymes, and it is about the recovery or the purification recovery of these proteases at industrial scale. So with this, I'll stop my discussion over here. Thank you for your kind attention. We'll continue our discussion in the next session. Thank you very much.